OpenAI just launched GPT 5.1, and in this video I'll be covering everything you need to know to consume GPT 5.1 and to build applications with it. I'll also show you a practical comparison of how the different models behave for the same task. Now let's first understand the difference between GPT 5.1, the model, and the two modes that they have introduced called GPT 5.1 Instant and Thinking. While 5.1 is the underlying LLM model that they have introduced, by default this model runs on auto mode. So when you ask the 5.1 model a question, it will decide whether to use its 5.1 Instant mode or its 5.1 Thinking mode. Let's understand the difference between these modes. The 5.1 instant mode is warmer and more conversational. Let's see an example. If you ask it a question like, I'm feeling stressed and could use some relaxation tips, instead of directly jumping in with action items, it takes a second to console the user that that's totally normal, especially with everything that you've got going on lately. And then it structures the action items to make it a little more easier to understand. It's also better at instruction following. Say I ask the model always respond with 6 words. If I ask GPT-5 where should I travel this summer, it sometimes ignores the previous instruction. But with 5.1, it's very particular to make sure that the response is only within 6 words. Another important feature is the 5.1 instance adaptive reasoning to decide whether to think before responding. This can save a lot of money and time. So this has two benefits. If you're using the model on chatgpt.com, the UI app, you can avoid endless loops of thinking for very simple tasks. More importantly, if you're building applications with agents using GPT 5.1, it can easily decide when to switch over to the thinking model, which will save you a lot of tokens, in essence, a lot of money. Now on the other side, the 5.1 thinking model has been made easier to understand and faster on simple tasks. And if it realizes that the task is more complex, then it takes longer and is more persistent. 5.1 Thinking's responses are also clearer with much less jargon. If you ask it to explain complicated concepts, instead of directly jumping into the explanation, it tries to explain one without jargon and then add a bit of context, which is typically how you learn complex stuff. Now let's look at what GPT 5.1 means for developers. OpenAI has released 3 LLMs for its developers to access via the API. GPT 5.1, GPT 5.1 Codex, and 5.1 Codex Mini. While the 5.1 excels at most coding tasks, the 5.1 Codex is actually optimized for long-running agentic tasks. The Codex Mini might not be as efficient, but definitely cheaper. Let's do a quick price comparison. If you add the amount of input-output tokens for GPT 5.1, it's 11.25, and it's the exact same for the 5.1 Codex as well. But the Codex Mini only costs $2.25 per million tokens. Now let's look at the overall improvements which this model brings for developers. Since 5.1 was much more token efficient, that means we save some money on the tokens. It also allows you to pass a parameter called prompt cache retention is equal to 24 hours. This extends the prompt caching, so the follow-up questions would have a faster response. OpenAI has also collaborated with IDEs like Cursor to improve the coding personality overall. Now, if you were using OpenAI previously, you would know that there was a field called reasoning effort that you could pass, where the values were minimal, low, medium, or high. Now they have added an option to set this as none in case you want a particular task to have no reasoning impact at all, hence saving the cost. OpenAI has also added 2 new tools. You can think of tools like MCP servers. Like here you can see that you've added a tool called Web Search, which allows the LLM to actually search the internet. So there are 2 new tools called Apply Patch and Shell, which are added with 5.1. So you would use Apply Patch if you actually want to make changes to your local files via a git diff. Practically, if you are using a tool like Cursor or Windsurf, you might not really need to do this because the IDE takes care of this for you. Similarly, if you want a model to interact with your local computer, you can use the shell command. Again, IDEs like Cursor or Windsurf already have this access. Now let's quickly test all 3 of these models in a local live environment. So in my Cursor 2.0, I have the option to run multiple models with the same task. So I have selected 5.1, Codex and Codex Mini. Now this option only shows up when you have selected the work tree model because it needs individual Git branches to run. Now I want to create a WhatsApp clone using React Native, Expo and Supabase. But before I actually start my development, I want to see a diagrammatic representation. So I'm asking all 3 models to give me a document to visualize this process. Now when I click on submit, you can see that there are 3 different agents running parallelly with 3 different models. 5.1, 5.1 Codex and 5.1 Codex Mini. Now typically Codex Mini would be the first one to complete because it's the fastest model. So you can parallelly see that there are 3 different agents running. Yeah, and you can already see 5.1 Codex Mini is already completed while the other 2 are still loading. The next to finish is the 5.1 Codex itself because it is optimized for AI agentic coding scenarios. And finally, the 5.1 model is also now completed. Now, this is an excellent way to compare the 3 models. You can see that a new file of 69 lines was created by Codex Mini. It's definitely faster and uses lesser tokens, but of course, the efficiency is something we'll have to look at. In comparison, GPT 5.1 created a file of 329 lines. Let's have a quick look at the file that got created by 5.1. When I click on open preview to the side, I see that there are some parsing errors in the mermaid files that are created. So I'll probably ask 5.1 to fix the mermaid errors. This would again take a little bit of time, but I want to check if this does fix the mermaid errors automatically without me having to manually fix it. While this is loading, just to explain, because I asked it to create a diagrammatic representation in .md readme files, typically there is a format that is used called mermaid, which can explain things visually much better. So an example of a working mermaid looks something like this. So it helps us visualize how different components of the application would talk to each other. So now you can see that most of the basic errors that were there were fixed, but I still get the overview of the app screen and navigation structure of a WhatsApp interface. Now, if you compare this to the GPT 5.1 Codex Mini, yes, I did get the same kind of parse errors, but after a couple of prompts, I was able to fix it. But if you look at the difference in the preview itself, the 5.1 Codex Mini gave me a very short document with one architecture diagram and a list of all the components. In comparison, the 5.1 gave me an app screen navigation structure. It gave me client-side layered architecture, Supabase database schema, so all the UML diagrams needed to actually build the database tables. It also gave me a sequence diagram of the end-to-end messaging flow of WhatsApp. It also added authentication session flow, media upload flow, so it was much more detailed. And finally, the 5.1 Codex, as you would expect, gave me a in-between answer with 2 diagrams and mostly the happy path scenarios.